Okay, welcome to this advanced session on machine learning. Today we will dive into two important topics in the field of machine learning, assembly learning and neural networks. Okay, these concepts are powerful tools that can significantly improve the performance of your models. So, what is assembly learning? Let's take an overview. Okay, let's start with assembly learning. Ensemble learning method combine multiple machine learning models to produce a stronger, more robust model. Okay, this idea is that by combining different models, we can reduce the risk of overfitting and improve overall prediction accuracy. So, assembly learning can be categorized into two main parts. First is bagging, and second is boosting. Bagging is short of bootstrap aggregating. This method trains multiple models independently and then averages their prediction, for example, for regression, and uses majority voting for classification. The most common example is random forest algorithm, which is ensembles of decision trees. Then we have boosting. Unlike bagging, boosting trains models sequentially. Each model corrects the error made by the previous one. Popular boosting algorithms include ADA boost, gradient boosting, and XG boosting. Okay, so now we know what is bagging and boosting. Let's see a difference between bagging and boosting. So bagging. Bagging involves training multiple models independently, such as random forest. The final prediction is made by average or using majority voting from all the models. Okay. Bagging works well when individual models are prone to high variance. Boosting. Boosting, on the other hand, trains models sequentially, where each of the model tries to correct the error of the previous one. This sequentially process makes boosting algorithm more sensitive to error, okay, often resulting in higher accuracy, but they can also be more prone to overfitting. Okay, popular algorithm includes ADA boost, grading boosting, and edge boost. Let's see an example of random forest, which use bagging and compiled decision tree. Okay, so here's the example of random forest in Python to classify the famous iris dataset. Okay. In this code, we are using random forest classifier to train a random forest on the iris dataset. The model uses 100 decision tree and we evaluate its accuracy to test. This is a simple but powerful example of how ensemble methods like bagging can improve the model performance. Okay, then let's have an overview of neural networks. Okay, so neural networks are classes of machine learning algorithms that are inspired by the structure and function of human brains. They consist of layers nodes, also known as neurons. Okay, the process information. The neural network made up of three main layers: input layer, hidden layer, and output layer. Input layer, this layer receives the input data. Hidden layer, this layer transforms the input data into the output data, and then hidden layer and more hidden layer. Then more complex pattern the network can learn. Okay, then output layer. This layer produces the final prediction. Okay, neural network are especially used for tasks involving complex patterns such as image recognition, speech recognition, and natural language processing (NLP). So let's see how neural network works. Okay, the core of neural networks is backpropagation algorithm, which allows the network to learn by adjusting weight based on the error of the output. Okay, each neuron in the hidden layer applies an activation function to the weighted sum of its input. Common activation function include sigmod. Sigmod means produces an output between 0 and 1, typically using binary classification. ReLU applies a inner transformation for positive input and zeros for negative inputs, which helps to avoid the vanishing gradient problem. The network learns by iterating over the training data and adjusting weight to minimize the error. Okay, using gradient descent. Next, we have example of neural network. Okay, so here's an example of creating simple neural network using Keras, a popular deep learning library in Python. We will use it to learn and classify iris data. Okay, so in this code, we use Keras to define a simple neural network with one hidden layer. The software Softmax activation in the output layer and it is used for multi-class classification. We train the network using categorical cross entropy as the loss function and the add-up optimization. After training, we evaluate the accuracy of the model on the test set. Okay, so conclusion. To summarize, ensemble learning and neural networks are powerful techniques that can help you to build more accurate and robust models. Ensemble learning improves performance by combining multiple models, and techniques like random forest and gradient boosting are widely used. Okay. Second, neural networks, on the other hand, are the ideal for complex tasks. Okay, especially when dealing with large data set and high dimensional data set. Oh, so that's it for the video. In the next video, we will discuss model deployment and how to take your trained model into production. See you in the next session.